All right, 9.2, we're going to be performing hypothesis tests for a population mean. And we do know the population standard deviation. So the population mean is going to be the null hypothesis. We're going to set up our test, whether we think it's less than, greater than, or different. First, we're going to use the critical value method. We're going to have a critical z-value that we're going to compare to our critical to our z-test value to answer our hypothesis test. So when we have the population standard deviation, we're going to be using a critical z-value and a z-test statistic. So this chart that you can barely make out, I'm going to be explaining by redrawing. This is based off the level of significance that you're told to use and what type of test you have, whether it's left tail, right tail, or two tail. All right, so in 9.2, we're going to have a critical z value. So if we say our claim is that we think the mean is less than what they claim. So the null is equal, we're less than, that makes it a left-tailed test. So the critical z-value is going to be a negative value. The level of significance is all in one tail. And whatever percent significance you're told to use, the z-value goes with that. If we say that we think the mean is greater than what we're told, our alternative is going to be greater than. This makes it a right-tailed test. The critical z-value is going to be positive. The critical region is going to depend on the level of significance that you're told to use, but you'll notice the whole area is in one tail. If our claim is that we think it's different from them or from the null, which means not equal to, this makes it a two-tailed test. This means our level of significance is divided between two tails. So the notation for the critical z values, plural, will be the level of significance divided by 2. This one will be positive and this one will be negative. And the area in the tails is the level of significance cut in half. Half for each tail. So this is a slightly clearer picture of what's going on up here. Where do I get these critical z values? We're going to talk about next. So when you're performing a hypothesis test, you're going to be told your level of significance. How accurate? You want to be 90% accurate, 95, or so on. So these level of significance will be given to you. This is a table for commonly used critical z values. You will have this table not only in your notes, it is table A20 for 9.1, table 9.1, I'm sorry. And I put it, if you have this from me, it's on the back of our T distribution. So to perform the hypothesis test, First, our assumptions are our sample is a simple random sample. And the sample size is either larger than 30 or from a normal, approximately normal population. Then we determine what type of test from the problem, which type of test is it. After that, we're told the level of significance. So if we have a left-tailed test and I want a 0.5 level of significance, because I'm told, I'm going to go to my chart. For a left-tailed test, the critical Z value will be negative 1.645. This sets up my critical area. Then we're going to calculate our Z test statistic. And if our test stat falls in the red zone, that means we are right. If it doesn't make it there, we are not right. And that's how we draw our conclusion. In the next video, we're going to be doing a hypothesis test from start to finish.